All right, so this is chapter 4C in the textbook. We are going to be covering area. So it should be pretty chill. You've already done this before, but we're just going to talk about all of this stuff again. So these are the learning goals, okay? So you need to know what an area of a 2D shape is. What 2D shapes are just the shapes you've already experienced. So like squares, rectangles, triangles, all that kind of stuff. You need to know how to convert between the metric units, but with area instead. And this also includes hectares. And you need to find the area of composite shapes. And to do this, you can either add or subtract stuff, but we'll get into the details a bit later, okay? So these are the common metric units for area. So we have square millimeters, square centimeters, square meters, square kilometers, and hectares. Now, this is a diagram that I would like for you all to draw. It's very important. Very, very important. Okay. So in chapter 4A, we had a conversion little thing similar to this, but the main difference between this area one and the one you drew earlier is this little square up here. Okay. So that little two. That little two just means we squaring it, aka multiplying the number here by itself. So if you type this exactly, so 1000 squared is the same thing as 1000 times 1000, vice versa, 100 times 100, and yada, yada, yada. Okay. So you need to know how to convert these units of measurements. Okay. So, yeah. Yes. There's also another one up here, HA. HA just means hectares. Okay. It's just e- another easier version of saying things. It's like saying it's like, for example, 1 kilometer is the equivalent to 1000 meters. You don't want to say 1000 meters, so we just say 1 kilometer instead, just to make our lives a bit easier. Hectares to meters squared is exactly the same thing. Now, hectares is mainly used to measure an area of land because land is like so big and vast. You can't just say 800,000 meters squared. So we just make our lives a bit easier by saying hectares instead. So this is the conversion right here. So in this example, cover these area measurements to the units shown in the brackets. So I have 0.248 meters squared and I need to convert it to centimeters squared. So just refer back to this little conversion diagram that we have here. To go from meters to centimeters, all we are going to do is multiply by 100 squared, okay? So what you'll write is 0.248, multiply this by 100 squared, and if you type this exactly in your calculator, oops, you will get, why is my enter button not working? But do note that it is pretty much 2,480 centimeters squared. Okay, make sure you put in your units of measurements at the end. Now, I don't know why this calculator is acting up. Let's try this again. Oh, there we go. So I have 3,100 millimeters squared and I need to convert it to centimeters squared instead. So to go from millimeters squared to centimeters squared, we are going to be dividing. Okay. So please make sure you press the divide button instead of your times. So if you just write this out, this will be 3100 divided by 10 squared. And if you type this exactly on the calculator, 31. So 31 centimeters squared. Also, for those of you who don't know where the square button is, it is pretty much this button here, highlighted in red next to the number 7, okay? Make sure you input your base first. So whatever it is that you plan on putting as your base, then you press the square button. So in here, if I need to do 100 squared, make sure you type in 100 first before you press this button, okay? Now, this is an activity. I'll let you try it on your own, but I'm just going to change this to meters squared. I'll let you try this out on your own. I'm just going to pause the video. I'll go do the solutions right now, and then you can just have a look at it, okay? Now, these are the solutions here. Now, for the second activity question, I decided to change it from centimeter squared to meter squared just to present a challenge. But all you have to do is, if you look here, we're going from millimeters squared to centimeters squared and then to meters squared, to regular meters squared, I mean. So what you're going to have to do is you are going to have to apply the conversion twice. Once by dividing your question by dividing 10 squared. Once you get the answer to that, you are then going to divide by 100 squared instead, okay? And that is exactly what I have done here. So in my first line, I went from millimeters squared to centimeters squared by dividing 10 squared, typed in my calculator, got the answer, and because this is in centimeters squared, I need to change this to meters squared. I shall now divide by 100 squared, okay? Just like that. Now, I hope that you've all been given a sheet. There's a little sheet that I have prepared. It looks like this. What I need people to do is fill in the formula as, the sides go, pretty much. And this is all in order as well. So you have this whole piece of paper here. I need this to be stuck in your books just to make life a bit easier. Now, these are some keywords that we are going to work with. We have L for length, W for width, H for height, and B for base. So the first formula we're going to work with is a square. So the formula of a square is in its final form L squared. But in reality, all that means is we are going to multiply L with itself. So basically, whatever side lengths the square is, you're just going to multiply that number by itself. And these little dashes here, every time you see a dash and they tell you what side length this is, every time you see that exact same dash there, it just means it's the same length, okay? That's all it means. So say, for example, if L is equal to 5, for example, and I wanted to find the area of the square, I'm just going to write down my formula, substitute my number in, and then figure it out that way, okay? Now, there's one more thing I wanted to point out. Let's say here, going back to my example, L is equal to 5. If they don't give you a unit of measurement, like for example, cm or like meters or kilometers or millimeters, okay? If they did not give you that, if it's non existent at all, okay? Non existent at all, what you need to write is units, okay? Unit squared. And I'll write it right here in purple. So this is the official unit that you will write down if in the case that the question that you were provided does not mention how long um, the, the side length is specifically, okay? So If they don't give you kilometers, meters, centimeters, or millimeters, you are expected to write unit squared instead. Okay. Let's go to a rectangle. So the area of a rectangle is pretty much similar to that of a square. Okay. So you have a length, you have a width. Okay. One important thing to note is that the main differences between a rectangle and square is that one side will be shorter than the other. Okay. And that's what the width is for. As you can see, the width looks a bit shorter as opposed to the length here, which is quite long. Okay. So say for example, I had my length be 7 and my width was 3 centimeters. Okay. So what I'm going to do is write down my formula, substitute what my L and my W is into the formula. So 7 times 3, which ends up being 21 centimeters squared. Please make sure you put in your units of measurements at the end, otherwise marks will be deducted. Okay. Parallelogram. So parallelogram is pretty much similar to a rectangle, but it's just been slightly angled differently, which you can tell from the sides here. So these sides are angled, but the length, aka the base in this case here, is pretty much the same. Okay, nothing's been changed about them. Now, the dashed line gives the height, okay? So it gives how high it is. It's technically the same thing as the width, okay? Very similar. So all you're going to do is take the base of the parallelogram and multiply it with the height of the parallelogram. So whatever numbers they give you, just substitute the numbers in, multiply them together. It's pretty straightforward. And last but not least, we have a triangle. So this is the formula here, half times base times height. Now another way of figuring out the area of a triangle is just multiply the base and the height together, similarly to the parallelogram. And after that, you just divide it by 2. So every triangle that you see is technically half of a parallelogram. And that is the best way to associate it. Okay. Very easy. Now, I will go through some examples here. I'll just write them out. Just pause the video if you want to copy any of this down. But yeah, let's just go through this. So I've labeled them question 1, 2, and 3. So let's just go through question 1 first. So question 1 here is a rectangle. Okay. I would always recommend by starting out what shape you plan on finding. Okay. So in this case, question 1 is a rectangle, and it's pretty clear to me because the length is 6 centimeters and the width is 2 centimeters, which is smaller than the length. Hence, it's not a square. So the next thing you should do is write out the formula you plan on using. So this is my formula of a rectangle. A is equal to L times W. And the final step is to substitute what I know. So I know the length is 6 and the W, or aka the width is 2 centimeters. So I'm just going to write 6 times 2. And 6 times 2 is the same thing as 12. Now at the end here, I'm adding centimeters squared just because of the fact that in my diagram, I have centimeters here. All right, for question 2, it looks a bit weird at first, but it looks pretty familiar to a parallelogram. Okay. Now, as you can see, they are oriented differently, but all you have to do is just tilt the parallelogram 90 degrees and it will look very similar to what we're quite used to. Okay. So instead of redrawing the shape, I can just label it as it is. Now I know this 8 meters here is going to be the base and this 3 meters here is going to be the height. So I know this is a parallelogram. Okay, so I'm going to write the formula for the parallelogram. I'm then going to substitute the numbers that represent the letters. So my base is 8 meters, and then my height is 3 meters. And then I'm going to calculate it. 8 times 3 is 24. And just make sure you have your units at the end because we're dealing with meters. You have meters squared. All right, so for question 3, I can see that this is a triangle. So it's pretty straightforward. I'm just going to write down the formula for a triangle, which is half times base times height, or you could just do base times height divided by 2. I don't care. I'm just going to do my way because I like this way a lot more. And that's just up to personal preference. Um, this 7 here will be the height just based off my diagram. And my 13 here will be the base. So I'm going to substitute my base and height into the formula. So it'll be half times 13 times 7. Now, if you type this into the calculator, you get this fraction here. To sort of bypass this, all I have to do is press this double arrow above enter, and I'll give you my answer in decimal form. Okay, so 45.5. Now, just be careful of the units. I'm dealing with meters, so it will now be meters squared. Okay. Now, this activity here, I'll leave you to it. I'll probably upload solutions here. Just give me a moment and I'll get it done. All right, so here are the solutions. Just have a look at it and then just try to understand what I did to break it down. But this is pretty much all it is, okay? So just pause the video, but it should be pretty straightforward. Composite shapes. So these are pretty much shapes made by putting two or more simple shapes together. So you got rectangles, triangles, circles, yada yada yada, the whole shebang. Okay. And then what you're going to do is you can either add or subtract depending on what you need to do. Okay. And I'll just go through that really quickly. So in my case here in this diagram, I have shape 1 and shape 2. I can see that shape 1 is a rectangle and then shape 2 is a triangle. So all I'm going to do is find the area of the rectangle first, then find the area of the triangle, add those two areas together, and that will be the total area for this weird shape right here. So for my first one, I'm going to label this as question 1 and question 2. And I can see from the get-go, question 1 looks a bit weird because I sort of see a rectangle, but I also see a triangle at the same time. So what I'm going to do is I'm just going to find the area of the rectangle first, then find the area of the triangle, okay? Now you might be wondering, oh, why did I say rectangle? It's because if I look at the exterior blue lines here, highlighted in purple, oh, like that, that pretty much makes up the three sides of a rectangle already. And this dotted red line at the top, that will be the last length, okay? And you're wondering, oh, what length is that? It doesn't really tell me. Well, you're pretty much given the answer already. Because on the bottom here, I can see from this end of the rectangle to that end is 10 meters. And on the dotted red line, I don't really see it overextending beyond that. Okay. So we can just assume that this is also 10 meters the whole way. Okay. What I like to do is write down the side length and then just draw arrows indicating where it starts and where it ends, just to make things a bit easier. So I'm just going to find the area of the rectangle first. I can just Draw another rectangle if I wanted to, label this as 10 meters, label the width as 6 meters, just find the area of this pretty comfortably. Say 10 times 6, which ends up being 60 meters squared. Okay. The next thing I can do is, if you were to sort of look at that dotted red diagram, if I were to shade this in purple right here, that purple shaded area sort of looks like an upside down triangle. Okay. Now, thankfully, we've been given the base, which is 10 meters. So I can actually just draw another diagram if I wanted to. So I'll just do something like this. That's 10 meters. And then the height is going to be 4 meters because that's what they gave us originally. Now, I can just use my formula for a triangle just to find out what the area is going to be. So it'll be half times 10 times 4, which ends up being 20 meters squared. Now, my original shape is actually this shaded blue area. This is my shape here. So as you can see, we found the area of the rectangle, which includes the blue and purple. And next, we found the area of the triangle, which is just the purple shaded area. Now, what we want is just to find this blue area only. So what I'm going to do after that is subtract the triangle from the rectangle. So you can do something like total area is equal to 60 minus 20, which ends up being 40 meters squared. Okay. So pause the video here if you want the working out. All right. Question 2 is where it sort of gets a bit complicated. So I've got this weird like Tetris block, and I can sort of see it being like a rectangle and all that kind of stuff. But there's actually an easier way to do this, okay? What I'm going to do is I'm going to separate these into two. So as you can see here, I'll draw a line just like that. So this will now be shape 1, shape 2, yada, yada, yada. Okay. Now, I don't think it's a square. It could possibly be a square, but I'm just going to assume that these are rectangles. So actually, shape 1 would be a square because over here, I have 3 millimeters and it's been marked with 2 dashes, while up here, it's also been marked. So just remember, a square is sort of all side lengths are exactly the same. And because these two are adjacent next to each other, adjacent just means beside or right next to each other, I could say that this would be a square. So shape 1 could be a square. Now, shape 2, it could be a square visually, but it's actually not. The reason being is because over here, I have 1.2 millimeters squared, but just above, which I've circled, this is 1 millimeters, okay? So this is in fact not a square, it's actually a rectangle. Now that I've broken this diagram up, I can actually just find the area of shape 1, which is a square, and shape 2, which is a rectangle. So this will be, so I can just draw a diagram here, labeling it as 3 to 3, and just find the area of shape 1. Which equals to 9 millimeters squared. Now I'm going to draw another shape and say that's 1.2, that's 1. Now it doesn't have to be accurate, but you sort of get the idea. So the area of a rectangle is length times width. So I'm going to have 1.2 times 1. Now I can't be bothered figuring it out by hand. You have a calculator, so you can just do 1.2 times 1. That will give me 1.2. So it's actually just 1.2 millimeters squared. I actually didn't even need to use a calculator because anything multiplied by 1 is just itself, pretty much. Now, because these two shapes are connected together, what I'm going to do is add shape 1 with shape 2. So I know shape 1 is 9 millimeters squared, and I know shape 2 is 1.2 millimeters squared. So if I add that together, it just ends up being 10.2 millimeters squared. And that's pretty much the final answer for question 2. Now, I'll leave you to it. Okay, just spend some time doing this. I'll show you the working out, and then the final side is just the questions right there. So just give me a moment while I fill this out. All right, so this is the solution to the first activity question, and this is the solution for number 2. Okay, good luck. Have fun. Bye.